the Great Basin Desert. This is the largest desert in the United States. It covers a vast area of over 200,000 square miles. Almost all of it hot, dry, and seemingly empty of human activity. Until you look more closely. Hidden in the dust and sand, archaeologists are uncovering clues about some of the first inhabitants of North America, known as Paleo-Indians, who lived here more than 12,000 years ago.
For more than a century, most North American archaeologists believe that the Clovis people, or the Clovis hunters, were the earliest hunter-gatherers in North America. We have found evidence of these Clovis points embedded between the ribs of now extinct megafauna such as large bison, mammoth, mastodon in the desert southwest of New Mexico and Arizona.
But old theories are being replaced, and the Clovis may not have been alone in North America.
In Nevada, we can paint a picture of an entirely separate Paleo-Indian culture that colonized the region. They're defined by their technology, and they had distinct projectile points and stone tools separate from the Clovis culture. They probably spoke a different language and had an entirely different culture altogether.
Recent discoveries have dramatically shifted our knowledge of these early people and revealed surprising new details.
This represents the earliest archaeology in the Great Basin. These people who use these points are the first real inhabitants of the Great Basin on any major way, first real residents.
Journey back in time to the end of the last ice age, before there was a desert. Join scientists as they use time-tested field surveys in tandem with high-tech mapping and computer modeling to uncover and rewrite this ancient story about the earliest inhabitants in one of the most remote parts of North America. The Great Basin Desert stretches across most of Nevada and half of Utah. Though it's a desert today, in the past, the landscape was very different. During the Ice Age, also known as the Pleistocene, for 2 million years, glacial sheets repeatedly covered much of North America. In the Great Basin, it was much cooler and wetter. The mountains were covered with forest, and the valleys were filled with massive lakes. Driving across Nevada today, it's almost impossible to imagine what the landscape would have looked like as the Ice Age ended.
I want to show you something amazing. I've pulled off of Highway 50 near Sand Mountain Recreation Area to look at this mountain that you see behind me. If you look at the mountain from the bottom all the way to the top, you see these lines carved into the mountain. Those aren't railroads, they're not highways, those are wave-cut terraces or ancient shorelines from a large and deep lake that once existed here. 17,000 years ago, the lake would have been all the way to the top of this mountain. From the air, you can clearly see how the waves of this ancient lake cut flat benches as they lapped ashore. Also, you can begin to understand the effects of climate change. Shortly after 17,000 years ago, the lake started evaporating due to warmer and drier climate, leaving behind a series of lower wave-cut terraces as the lake level dropped. Throughout the Great Basin, you'll see evidence of these wave-cut terraces like the ones on the mountainside behind me, evidence that this area of Nevada and the Great Basin was once teeming with ancient deep lakes. So just to get it straight, 17,000 years ago, standing where we are right now, we would have been approximately 400 feet underwater.
During the Ice Age, there were extraordinary animals that roamed the landscape, animals on a scale much larger than those that are found today in North America.
This group of big game was collectively known as Megafauna. Here in Nevada and the Great Basin, the Megafauna included a wide diversity of animals. They included herbivores or grazers such as mammoth, giant bison, llamas, giant camels, and some predators who would have hunted them. These interesting predators included giant short-faced bears, dire wolves larger than modern gray wolves, and even a critter that we call the North American cheetah.
As the Ice Age ended and the climate changed, many of these large animals were stressed and pushed toward extinction. Into this ancient landscape, humans arrived. Dr. Darren Duke has spent his career as an archaeologist in the Great Basin, working at hundreds of sites, painstakingly piecing together the story of some of the earliest Paleo-Indians who lived here. Duke knows that wherever there were lakes and wetlands, there were probably people too.
If you were to drive across Nevada in the Pleistocene, you'd have seen more pine trees, you'd have seen less scrub, and you may have seen various oases of wetlands. And every valley, every time you see an empty playa, a flat, white bottom of a valley, that valley may have been filled with water, may have had cattails and bulrush and full of all kinds of wildlife. Small mammals, ducks, geese, all kinds of birds, and game animals that would have been all around the margins and in the wetlands. It would have been an open smorgasbord. We know that a wetland is a good habitat for people. There's a lot of nutrition, a lot of calories, a lot of good things to eat.
Every wetland that Paleo-Indians might have hunted or rested at holds the promise of finding an ancient projectile point or tool. But how does one identify these places amidst a landscape that has changed from marshlands to sagebrush and sand? Duke teamed up with fellow archaeologists Dr. D. Craig Young and Jerome King to develop a geographic information system, or GIS model, of where the ancient lakes were once located.
Why don't those channels follow gravity now the way they did in the Pleistocene? What's changed?
I think there's been some post-lake warping in that north end of the basin out there.
So we know that Paleo-Indian people were attracted to these giant Pleistocene lakes and the wetlands around them. And we also know that the lake levels were constantly falling and that the locations of these favored environments would be changing all the time. So we wanted to get a sense of exactly how fast that change was occurring and where we should be looking for sites. So we built a computer model that essentially considers some things about the lakes, like their elevation and the ambient temperature and the shape of the basin. So at the beginning of the model, we have all the lakes at their high stand about 15,000 years ago. And then we just start to evaporate them. We basically pull the plug on each lake, and we see each lake start to evaporate. And you can see that some of them evaporate quite quickly because they're smaller, because they're at lower elevation, and others are more long-lived. We do know that this all happened within the first few thousand years of human occupation. So by about 10,000 years ago, these lakes would have been mostly all gone.
With the help of a grant from the Bureau of Land Management, Duke and Young focused their attention on 2 dry lake valleys in Lincoln County in southern Nevada that were only 10 miles apart.
Cave Valley was a lake bed that disappeared early in this sequence of our lakes. Lake Valley was one, the nearby lake, was one that disappeared a little bit later. And all these are in Lincoln County where our researchers focused. So we took this time frame, some 13,000 to 9,000 years ago, and just for simplicity's sake, this lake that disappeared early should be restricted to the archaeology of the earliest people in that 4,000 year time frame. If you go to Lake Valley, you should have people were there the entirety of it. And so if we find archaeology here that is a little different than the archaeology over there, we can say something about how people dealt with the change through time and losing some of these options they had to live in.
The computer models have identified hundreds of miles of ancient shorelines, but now the search for artifacts has to be further narrowed to areas where ancient people might have camped. As a geoarchaeologist, Dr. Young helps target these areas through his understanding of landforms and their influence on how people lived.
The best places for finding Paleo-Indian sites is where fresh water entered these drying basins, creating habitat for insects, vast flocks of birds, small mammals, and large mammals. For Paleo-Indians, this was the ancient equivalent of a vast grocery store. Let me show you some maps. Here I'm looking at eastern Nevada on satellite imagery. Lake Valley is on the right, Cave Valley is here on the left. Let's examine Cave Valley a little bit closer. I can identify ancient shorelines in this now dry landscape. Here's one, and a little bit lower, there's another. We know that marshes have the best potential in 1 to 6 feet of water. Using our GIS tools, I have superimposed at each shoreline a 6-foot water depth to predict where the ancient marshes may have been present. Here we see in the purple a relatively high lake stand with a thin band of marsh. As the lake dried, we see in the brown that the wetlands expanded and may have been more productive. As the lake continued to dry, the area of potential marsh became even greater. Look at these 3 areas. Our GIS model has shown us areas of past marsh potential. Going back to the satellite imagery, I can also see the freshwater inputs. Here we have paleochannels on the east side of Cave Valley and another set of paleochannels on the west side. It's the intersection of these paleochannels and the modeled marsh potential that leads us to the grocery stores that Paleo-Indians may have relied on. So I've marked a few places, and we're going to go take a look at them. I'm going to get the coordinates, load them in my GPS unit, and head out. And when I get there, that GPS unit's going to be valuable, because all it's going to look like is playa and sagebrush.
Nevada is known for the zephyrs that blow through here, and we struggle with it during field work. Every day you get blown around, your paperwork gets blown around, your hair gets blown around. It's just a weather pattern in Nevada. You just get used to it. But in Utah, scientists have determined that there's up to 15 centimeters of sediment being eroded off the playa every year. So if you think about that over 14,000 years, how much sediment has been eroded and transported, it's quite amazing, the power of the wind and the impact and the implications for archaeology.
It's a high fly ball center field. Polanco on the move, still on the move.
As Young arrives at the GPS coordinates he pinpointed back in the office, he sets to work looking for the remains of a buried marshland. The marshlands would have decayed and dried up as the ancient lakes receded. The remains would have been buried by dust and sand and compacted into a dark, below-surface layer known by archaeologists as a black mat. If found, the organic material of the black mat or marsh layer can be sampled using radiocarbon dating.
I believe that the buried wetlands at this location are about 80 centimeters below the surface, and I'm hoping those are the wetlands of the late Pleistocene and Holocene transition. Right now I'm about 50 centimeters. Let's go a little farther. Let's get a little hard. Looking for that buried surface. I found it at other locations. I suspect it would be here. Okay, here it comes, possibly. There we go, getting a little darker. That's the deposit that I would sample. Hopefully there's a little bit of organics. So right here we've begun to see a change in the profile. Got a little gravelly, a little organic, more organics, and we can see it's slightly darker. Sand, a little gravelly sand. I'm hoping there's some organics, and I want to sample this deposit, see how old this part is.
Lab analysis dated the black mat at 11,400 years old, meaning this area was a productive marshland, and Paleo-Indian sites might be nearby. Archaeological teams are now ready to see what they can find. For 2 weeks, they'll operate out of a desert base camp and live in the summer heat. They'll systematically survey the ground along where the GIS model predicted ancient shorelines to be, and will also conduct targeted surveys in the specific areas that Dr. Young has pinpointed.
We're lined up on a UTM line, northing, and then we're going to walk easting line. We're each spaced out 30 meters apart, and we'll walk 500 meters, turn around, come back, and just keep doing that so we have a systematic coverage of the area.
The archaeological teams are not only looking for evidence of how the earliest residents of the Great Basin lived, they are also contributing to the bigger story of who first came into North America and when. Early theories about the first humans in North America suggested that they all came over the Bering Land Bridge from what is now Russia and down through Alaska during the last ice age. This group was known as the Clovis people. The first artifacts of the Clovis people were found in the 1920s and 30s in New Mexico.
For more than a century, most North American archaeologists believe that the Clovis people, or the Clovis hunters, were the earliest hunter-gatherers in North America. This group is known to have manufactured a very unique spear point. It was a large spear point that was concave-based and basally thinned or fluted to help attach it to the spear. These Clovis people, we know that they were big game hunters. We have found evidence of these Clovis points embedded between the ribs of now extinct megafauna such as large bison, mammoth, mastodon in the desert southwest of New Mexico and Arizona.
However, more recently, archaeological evidence from sites in the Great Basin, as well as the Pacific coast of North America, suggests there was a second type of hunter-gatherer that was probably contemporaneous with the Clovis people. This second group is known as the Western Stemmed Tradition.
The people of the Western Stemmed tradition used a very different technology to manufacture their spear points compared to Clovis points. Western stemmed projectile points don't have concave bases to them. They weren't basally thinned. They just had typically an elongated base to them. So technologically, the two spear points are as different as night and day.
The unique spear points of the Western Stemmed Tradition and the distribution of artifact sites found in the Pacific Northwest lead a growing group of archaeologists to believe that the makers of these tools may represent a separate migration of people into the Americas, along the Pacific coast and then inland into the Great Basin.
What really compels me going forward in my research, just to keep working out here, is at both ends of the spectrum of this time period. At the early end, we have some data that are challenging the current views, maybe even how early the Western STEM tradition was here compared to perhaps other cultures such as Clovis. On the other hand, how did it end? We know that when these lakes went away, so did this technological tradition, at least, and perhaps the cultures that made them.
While many archaeologists are excited about these new migration theories, Darren Duke and his archaeological crews are keeping to the task at hand, finding the facts on the ground, the artifacts that will help him understand the lifeways of these earliest inhabitants. Duke has positioned a survey crew in each valley. The Cave Valley crew is led by Sarah Rice, the Lake Valley crew by Mike Lindsay.
Okay, so what we just did was finish our first 500-meter block, and we found 2 isolated artifacts. The first one was an obsidian simple flake tool, and a fresh obsidian flake is the sharpest thing in the world, sharper than a surgeon's scalpel. So it would have been a very effective tool for butchering game or processing some other resource out here. The other isolate that we had was a milling slab, and that would have been used to grind nuts and seeds. And unfortunately, milling slabs post-date about 9,500 years ago, so after the Paleo-Indian period. So although it's cool, not quite what we're looking for right now. Okay, so that's 1 block down, about 4 to go. We've been out here for a couple hours now and have another 6 hours to go. We'll be doing the same thing all day. All right, guys, let's get to it.
For most of the crew, getting back to camp is a chance to clean up, get cool, lay low, and re-energize before the next day's work.
Well, eating for lunch cold Chef Boyardee and pre-made tuna meals, so it has little crackers in the tuna and everything. For dinner, hot dogs.
You know, first meal of peanut butter sandwich and beef stew was lackluster.
I did a lot of experimentation. I made a gumbo kind of thingy in foil packets and marinated some meat and just kind of give myself some variety. But towards the end, it's just going to be add water and eat.
We like to do experimental flint knapping to just try to get some personal experience with what it was like to use the stone, what kind of investments there are, how hard it is to pull off certain forms, and just really relate a little bit to the record that we find.
Honestly, the view is great. This morning I love seeing the clouds rolling over the hills, and so I enjoy just looking at nature and being out in nature. By about day 6, you start counting down the days that you get to go home. And, you know, dreaming for a nice real shower in bed. maybe eat out at a restaurant.
It's like our house, you know, we, us, just like all these. Yeah.
The search for artifacts in Lincoln County continues over the next 2 weeks. In Lake Valley, Mike Lindsay's crew has finally found an older paleo site.
Let's get 3 overview photos from opposing views. I'd really like to show this drainage here. And just what we have found here is a small stemmed point. Based on its width to thickness ratio, it's quite thick for its overall size. It likely would have been a much larger artifact at one point in time. And these margins on the base here are ground, intentionally abraded, so that when it was sitting in a shaft, and sinew was wrapped around it to hold it in place, these margins wouldn't be sharp and cut the bindings. Okay, so this site is actually a very interesting location. It's located on a terrace, slightly elevated above the playa floor, that gently slopes down to the lake. We also have a drainage at the north end of the site that would have flowed into the lake. So the people camped here were sitting just south of this drainage and just above the playa. So 10 to 12,000 years ago, this would have been a great location. And based on the western stem points that we've found here, we can estimate that's about the age of this site. Well, this fits our model nicely because Lake Valley should have had water for a longer period of time than Cave Valley. So Cave Valley should have earlier Paleo-Indian stuff, whereas Lake Valley should have early and late. Because when the lake dried in Cave, people still would have been around the lakeshore here. And what we found here, it looks like to be a later Paleo-Indian. So this fits the model.
In nearby Cave Valley, Sarah Rice and her crew have started to survey an area Dr. Young has pinpointed through his auger samples.
This is an area where D. Craig did his core nearby, and I think he found what may be an old wetland. And so this may be a shoreline near a marsh where people were living. And so we're going to flag out the site and see what comes of it, see what tools we find.
As Sarah Rice and her team spread out over the site, they place flags next to the artifacts they discover. It's a big find. Many broken ancient projectile points, scraping tools, and flakes dating back thousands of years. By examining the way in which these were created, Duke can immediately classify them as Western-stemmed tradition.
Yeah, this is perfect. This site, we've got a fragment of a western stem point, just like the kind we're looking for. This would have been a Cougar Mountain style. It's the middle of it. It would have had a long tapering stem down here. And then these are the shoulders, and this is the blade. And in fact, we have the tip that refits to this laying on the ground over here. It's right here in the sand. Let me get that and show you. Imagine a long tapering stem at the bottom of that, and you've got a perfect Cougar Mountain style projectile point. This would have been 12,000 years old or greater. It's sitting on this landform that we suspect was used to be a high spot just above the marsh. And this is a quintessential item we've been looking for. This is a really exciting site, and I hope we can sweep here and find some more of these.
I saw one, I think, over here.
Oh, these are two very small clips on OBS.
Oh, yeah, sure knows it.
Oh, this is just getting better all the time. Okay, so this is a perfect example of a stem point, a long stem point at this site. We've got 3 or 4 of them. This one is a red chert, and you can see the long stem. It's got a ground edge, very symmetrical. It would have extended down here. It broke some length. But what's interesting about this piece is that they've repurposed the tip. It's not pointed anymore. It has this square top, and that's because people would just bevel it into kind of a 2 different angles on each side, and then they would take flakes off of 1 flake off each side to get this square sharp edge. And we're not positive what they were doing with it, but microscopic analysis shows striations lengthwise going down from the top that indicate it was probably used for some sort of punch, maybe for leather, but we really aren't quite sure. Well, when I see this many flags in this area here, I just think we have a perfect site, exactly what we were looking for. We can find the points. We know we have several of them here, 3 to 5, I think. We have all these flakes from people making and resharpening tools, whether as a group of hunters moving through or whether it was a small family band, I don't know. know that right now, but it's definitely a living space for probably some period of time, a few days maybe. But it looks like we have more material than somebody just sitting down and eating lunch and doing some rock breaking.
The computer-based mapping strategy has led Dr. Duke and Young to their most significant finds and confirmed their hypothesis that lake evaporation models could help predict where Paleo-Indian sites might be found. Only older Paleo-Indian artifacts could be found in Cave Valley, artifacts ranging between approximately 13,000 and 11,000 years ago. 10 miles away, in nearby Lake Valley, the paleo artifacts found ranged in age from roughly 13,000 years to 9,000 years of age, reflecting the fact that Lake Valley was habitable for 2,000 more years before it dried out. Their survey of Lincoln County, Nevada, reveals new findings and enhances our understanding of early prehistory. In these valleys, as the Ice Age ended, there were once ancient lakes with rich marshlands, and along those shores, the people of the Western stem tradition hunted and lived. Just 1 month after wrapping up their investigation in Cave and Lake Valley, Duke, Young, and their archaeological team travel a couple hundred miles north to excavate a site in the Bonneville Salt Flats of western Utah. Here they would unearth a surprising new find, one that would amaze them and write a new chapter in the story of the first inhabitants of the Great Basin. The Bonneville Salt Flats, west of Salt Lake City, Utah, are 40 square miles of hard, flat salt pan. They and the Great Salt Lake are the remnants of prehistoric Lake Bonneville, which covered over 20,000 square miles. Today, this area is better known for the land speed record set at the Bonneville Speedway than it is for archaeological sites.
In the late Pleistocene, Lake Bonneville was by far the largest lake in the Great Basin. But as it dried, it was replaced by a spring-fed delta and vast marshes in its western desert. The wetlands decayed and died. Large parts of them were buried, while others eroded away. That's the nature of the desert. Today, the reverse is happening. Places are being exposed by wind and water, revealing paleo-wetlands and possibly Paleo-Indian sites. If we zoom in on the imagery, we can see these dark areas. These are the newly exposed black mats from the ancient wetlands. I like to think of this as an onion skin. Layers are being gradually peeled away, seasonally even, and these are the areas that we want to go look.
Duke and Young have been working in the Great Salt Flats for over 17 years. These days, they have come to rely on the GIS computer modeling and satellite imagery to guide their ground searches for Paleo-Indian sites.
All right, so we'll start out the day on this channel down here where we've been finding sites. It cuts right across our survey area, right over there.
That's where the black mat is.
That's where the black mat is, and one of these main channels that it looks like these really early folks were living on.
We should get some good exposures there. Let's get the crews out there. That'll be cool.
Just off to the side.
In the heat of the desert summer, Duke's archaeological team sets out to survey the newly exposed black mat areas seen on the satellite photos.
I marched our crew out here on day one just because it was an interesting area. And within 100 meters after lunch where I sat there and discussed, why can't we ever find a fire feature? If we can find artifacts eroding out of the ground, we should find fire features, maybe. Within 100 meters of our survey, somebody said they had artifacts. I went over and looked at them.
So Darren called me over. He had found some flakestone tools, and I saw a piece of charcoal on the ground around where he had found it. And so I picked it up and smudged it on my fingers and instantly realized that I had a carbon, charcoal, and a fire pit here around these cluster of artifacts. And so we started looking closer at the ground and found bone coming out, eroding out of the ground.
The charcoal was sent to a lab where it was identified as willow wood and dated at 12,300 years old. They had found a prehistoric fire pit dating 1,000 years older than any other known open-aired feature in the Great Basin.
So as you can see here, we're working at the site. And let me show you a little bit about the key feature of it, what brought us here in the first place. This dark stain here is an old Paleo-Indian era hearth feature. Basically a fire pit or a cooking feature, however you want to look at it. But you can see the stain kind of going around this area. We came out here originally about a year ago and we dug this one square just to see if we saw, what we thought we saw was real. Right here, the earth is hardened, and that's just from being baked, being just directly below the feature. We have a piece of bone right here behind our grid string, big piece of charcoal there. So we see that this fill has a lot of artifacts still in it, and we want to recover all those artifacts. We're going to continue down beneath this in the area here and all around it, and we're taking all the sediment. We're going to take it back to our lab and run through all of it with fine screens to get every little bitty piece of data that we can get.
As the archaeologists' team began to systematically excavate the fire pit, they learned more about what these ancient people ate. Instead of megafauna, big game, they found goose and duck bones. Because of the abundance of waterfowl bones, they named it the Wishbone Site.
As we've been excavating this site, we see especially the fauna of the wetlands, the ducks. We have several species of ducks at this site that we've exposed already. Their preservation is astonishing for being 12,500 years ago. They're just eroding out. That's how we're recovering them in place along with the large projectile points, which is kind of inconsistent when you think about duck resources and big projectile points. We have not found the larger game that we expect were also attracted to the refugia of the wetland. But we continue to look, and we're hoping that the more carefully we excavate some of these places, the closer, now that we know where to look on these eroding landforms, we may encounter the resources that were the target of the large projectile points.
Just like they found 200 miles south in Lincoln County, Nevada, the large projectile points found here at the Wishbone Site are in the Western stem tradition, and specifically known as the Great Basin style called hasket.
This is a hasket point. It's a perfect version of one. It looks like it's been reworked, and they can be much longer than this, but the significance of this thing is that it is intact in the ground, sitting 1 meter from a hearth feature we know is 12,300 years old. There's no direct evidence of hasket at that time, outside of some loose associations, and there's no context like this. So this is really unprecedented, and it's a perfect version of one. We found it just 1 centimeter below the surface. We think these are spear points used to hunt large game, and by large game I mean extinct Pleistocene fauna as part of that profile of game. We have another one of these we found just less than a quarter mile south of us that tested positive in a residue study for the elephant family, which in this area would be mammoth.
After a week of careful excavation, the artifacts, bone fragments, and plant remains were sent back to the labs for further analysis.
Maybe the most exciting element of it is that we found tobacco seeds in it. Tobacco seeds aren't common things to find in features of any time period, and in fact there's not really direct dated evidence of tobacco use in prehistory in the Americas prior to 3,000 or 3,500 years ago. So if this holds up to be human use of tobacco, we're pushing the date back on that 8,000 to 9,000 years. And this would have meant, as the earliest inhabitants of this area, that people in short order upon arriving here learned how to find and use tobacco. And this is important. It's important to me, for one thing, because it's an interesting social aspect of these people's lives.
It's been like a needle in a haystack, trying to find something that is dateable, something that is related to humans being out here that we are able to date. And so to actually find it and have a hearth, a fire pit that we can use to find out what Paleo-Indian peoples are eating and how they're living and how they're using this environment when it was a beautiful wetland, and then be able to date it to 12,300 years old is just an incredible find for archaeology and the peopling of the Americas in general.
One of the questions that really haunts this research is that we've been following out this record of these large spear points and what we think should be people following large game animals, even now extinct Pleistocene megafauna, through these big wetlands. And then we found a site that shows them eating ducks alongside these spear points. So the question is, are these spear points really what they would seem to be? We don't necessarily have to expect that megafauna was on the plate every night. And, for all the steaks I eat, I'll usually find banana peels and eggshells in my trash can. So this is really what we think life was like in a really bountiful marshland environment. People would have eaten what they could get hold of very easily. We don't know how often hunting these large game animals took place.
We have found out a great deal more about how the Western stem tradition hunters and gatherers made a living. They ate fish, they ate goose, they ate sage grouse, pronghorn antelope, mountain sheep, mule deer, jackrabbits. Western stem tradition people ate a vast diversity of resources.
Each new bit of information fills in missing pieces of the migration story. All the artifacts found in Lincoln County and at the Wishbone site in the Great Basin were made by the people of the Western stem tradition. Clearly, they were some of the first residents in this region. The projectile points they left behind are part of the Western stem trail that their ancestors took. A trail that some archaeologists believe may have crossed the Bering Straits and followed the Pacific coast south, until finally some would come east into the Great Basin.
These people would have been the earliest true residents of the Great Basin. They came into the area and they could use it how they wanted. It would have been a very good time for them, as I see it. Our evolutionary history is as hunters and gatherers, and nothing could suit us better than coming into an empty habitat and doing with it what we will.